Okay, what I'm going to show here is how to measure channel power on the Tiny SA Ultra. Here is a digital FM signal. This is also called HD FM or IBOC. It's the digital version of the modern day FM channel. Here's the analog channel in the middle, and these are two OFDM sidebands for digital program material on either side. So this is a modern day FM broadcast station, but we want to see how wide it is and how much power we have. So the first thing we do is we tap the menu and we go to measure, you'll see that, and then touch more, and then you'll see channel power right up here. Now, I know that this FM station is on 103.5, so we're going to do 103.5 megahertz. And I know the bandwidth is around 425 kilohertz. I think that's right. We'll find out. Kilohertz. And boom, there you go. So now we have a blue line here and a blue line here that represents the width of the channel that we'll be integrating. And we can show you that within that time, right up here at the top, it says that 99.9% of the power is at minus 66 dBm in a 425 kilohertz bandwidth. So that's telling you that it's integrating the power from this blue line here to this blue line here. Now, there's one thing you can do to make this readout a little more stable, and that is to average the trace over 16 traces. So I'm going to go back and I'm going to go display, trace, and then I'm going to say calc on, so you tap the calc off and it turns calculate on, and then I'm going to say average 16 traces. And so now if you watch, you'll see that each time the analyzer sweeps, it's going to take the 16 successive traces and average them together. And what that does is it gives you a much more stable display. This modulation, of course, is one of the things that's causing the variability. And then we can even turn on the low noise amp if we want to. Go back to the beginning and select level, LNA on, and that will improve the noise figure of the spectrum analyzer just a little bit. So now what I have is I'm measuring channel power. I'm averaging 16 traces because I've turned on trace averaging, and I'm doing it with the LNA on as indicated here. So now if we look at the channel power number right up here, it says minus 68.1, and it's bouncing around a couple of tenths of a dB. But that's how you get a stable, accurate channel power measurement. So that signal off the air from my antenna here is producing a received signal strength of 68.9, roughly, dB. It's varying a few tenths of a dB. And that represents 99.9% of the channel power. And 0.1% of the channel power is over here on this side, and 0.0% is over here on this side. So it tells you the relative power numbers, but this is what we're looking for. We're looking for the integrated power in this band, and it's this number right here. So I hope that helps.